All right, we're back. We are on page 9 of notes 12 of Calc AB. We're talking about definite integrals. We're gonna do like a weird version of a definite integral problem now. I kind of like them, but it takes a second to kind of like get into this, right? So we're given that the integral from -6 to 4 of f of x dx is -5, from -2 to 4 of f of x dx is -8, and then from -6 to 5 of f of x dx is -1. So we're given these three things. Then we're asked a bunch of questions, but like what's happening? So we know, so here's how I do these. It always reminds me of like when you're little and you have like blocks that are like, they're usually like different colors, and they're like rods, I guess. And so you'll have like one rod that's like this, and then you'll have another rod that's like this, and then I don't know, another rod, I need a third color, another rod that's like well, that's not good, like this maybe, right? And so like you know that by rearranging these that you can do like so I could do this rod minus this rod will give me this amount, or I could do this rod minus this rod to get this amount, or I could do this rod minus this rod to get this amount. That's how I handle these. So what I do is I think of the number line basically, right? So we have -6 to 4, we have -2 to 4, and we have -6 to 5. So if I were going to draw that, I would say I have, where am I doing this? I mean, all right, I'm going to do it here, and then I'll just like erase if I need to, I guess, or like when I need to. So this is like -6 and 4. And I know the value of that. I know that this is going to be -5. And then I also have -2 to 4. So -2 to 4 is maybe like here. You got to kind of like line them up. -2 to 4, right? And I know the value of that's -8. But if you look at it, you now know if you do -6 to 4 minus -2 to 4, you're going to be left with -6 to -2. And I had to do this value minus this value. So I can actually write that. We actually inadvertently sort of just did the first problem. So this should be -6 to 4 of f of x dx minus -2 to 4 of f of x dx. That's going to leave me with -6 to -2. And that's what I wanted. So that's going to be the value of -6 to 4 is -5 minus the value of -2 to 4 is -8 overall 3. That's how I do it. I do them all like these little block problems, like you're playing with blocks. So what do we want to do here? I need to get 4 to 5. 4 to 5. 4 to 5. Oh, okay. So 4 to 5, I'm going to do -6 to 5. Right, so that's -6 to 5. And then I also know -6 to 4. -6 to 4. So if I do this thing minus this thing, I'm left with just this, which is 4 to 5. So I'm going to write that down in exactly that way. So I want to do the integral from -6 to 5 of f of x dx minus the integral from -6 to 4 of f of x dx, which is, now we fill in the values. -6 to 5 is -1. What are you doing? -1 minus -6 to 4 is -5. So -1 plus 5 is 4. And that's it. And I enjoy doing these problems, kind of for that reason. So let's change it first. We'll say u is 2x, so dx is 1/2 du. So try not to forget that 1/2, mostly talking to myself. X is 2, means u is 4. X is -1, means u is -2. So this will be 1/2 the integral from -2 to 4 of f of u du. And I feel like that's the first problem we did. -2 to 4? Nope. -2 to 4? Nope. -2 to 4 is actually given. Okay, -2 to 4 is just -8. So 1/2 of -8. And I think this is about the amount of work you should show. Like it's annoying to write 1/2 of -8, but like it shows the person who's trying to grade it. It shows you if you made a mistake. like where did things go wrong? So I recommend that you actually show the work. U is x over 2, so 2u is x, so dx is 2 du. And then if x is 10, u is 10 over 2 is 5. If x is -4, u is -4 over 2, so -2. So we're going to get 2, the integral from -2 to 5 of f of u du. Do we know that value yet? I think we don't. Okay, so -2 to 5. -2 to 5. Well, I know -2 to 4. And I know 4. Oh, okay. Okay, I know -2 to 4. And I know 4 to 5. So I should just do -2 to 4 plus 4 to 5. Let's do that. So this is going to be 2 times from -2 to 4 of f of u du plus, well, so now do I want to distribute the 2 or do I want to do 2 parentheses? I think I should do 2 parentheses. I feel like that's a better way to do it. So let me move this over a little bit, move all of this over kind of this way, put in a parenthesis, and then 4 to 5 of f of u du. So 2, and then -2 to 4 is -8, plus 4 to 5 is 4. So we're using previous answers, and so that's always risky, but there's no avoiding it with these problems. So I think we got that. We haven't had to use our little like toys on these problems, but that's okay. Oh, new problem. Okay. I don't know. Let's see if we can do it. So we have a different setup. -2 to 2, 2 to 8, -4 to 2. All right. So we have to go from -4 to 8. So if I go from -4 to 2 and then 2 to 8, that should take care of that. So it's helpful to like draw all the ones that you know, but like you don't really need. I don't know. I mean, it's helpful. I'll do it. So what I'm gonna do this time is I'm gonna make a number line, and we'll go. So what needs to be on here? -2, 2. Oh, -4 needs to be on there. -4. Great. -4. -2. It doesn't even need to be accurate. 2, and then 8. All right, so what do we know? We know -2 to 2, right? That's a thing that we know. So we know that one. And then we know 2 to 8. Okay, so we can use that if we need to. And then we know -4 to 2. And so you can kind of like maybe almost anticipate the questions. It's like we can find this for sure. We can find this. We can find this. Like there's a lot of things that we can find. So, and that's probably what we need to do. So -4 to 8, I just need to go from here to here and here to here. So let's add those. Let's use that color, I guess. Nah, let's switch to black. So equals -4. That's how you save that, to 2 of f of x dx plus 2 to 8 of f of x dx. So that's going to be -4. -4 to 2 is -3 plus 2 to 8 is 4, 1 overall. All right, -2. Oh, okay. So -2 to -1, which I don't have, but it's f of 2x. So first up, u-substitution. So u is 2x. So 1/2 du is dx. That might be the most common dx. It's hard to say because I don't believe anyone's ever done like a thorough study on that. So u is -2, x is -2, u is -4. So we're really doing 1/2 from -4 to -2 of f of u du. Do we know that -4 to -2? -4 to negative, okay, so -4 to -2. I'm gonna go -4 to 2 and then subtract -2 to 2. -4 to 2 minus -2 to 2. So this will be 1/2 parentheses -4 to 2 of f of u du minus -2 to 2 of f of u. What am I trying to do? -4. Oh yeah. Okay, I got it. Maybe a little confused for a second there. F of u du. Okay, 1/2 -4 to 2 is -3 minus -2 to 2 is 3. Half of -6 is -3. I think it's -3. Again, if I make a mistake, like, what are you going to do? I'm going to do u-substitution on this for sure. 2, so this will be dx is 2 du. So if x is -4, then u is -2. And if x is -8, then u is -4. So we're doing 2, -4 to -2. That seems familiar. I think we know that one. -4 to -2. Did we just do -4 to -2? We did. We did it, but we didn't really write it down. But -4 to -2 is this. So that's going to be, I'm just going to use that. I'm going to say it's 2 times -6. And hope that's right. 2 times -6 is -12. Okay. So we got one more to do. -8 to -2, but it's f of the absolute value of x. So f of the absolute value of x is an even function. So like if I were going to draw a function, say I'm just drawing it, right? So f of the, like if this is 0, then the part from 2 to 8 of this has to look exactly the same as the part from -2 to it's a mirror image of it, which like seems like it should be an option, but I don't really know how to do that. So these have to be the same. So this is actually, usually you double it, because usually you're going from like -8 to 8. We're not doing that here. Here we're going to say this is equal to the integral from 2 to 8 of f of x dx. And the question is, do we know that? So that's why I'm doing it. I'm doing it because of the symmetry. So from -8 to -2 should look exactly the same as 2 to 8, but reflected. So it should have the same area. And 2 to 8 is actually given. So that's 4. That seemed easier than maybe, I don't know. But anyway, I think these are all pretty good. Any mistakes? I don't know. Let me know. I think it looks good though. I definitely recommend that you use this little, go back to when you were a child and you played with little like toys and you just got a sense of addition from those toys, and now you can use it on definite integrals. So like that's pretty useful. All right, so I'm gonna end this here, be back in the next video and do the last page notes, and I will see you there.